Hello and welcome to part 2 of lesson number 5 in unit 0 of our grade 10 academic math class. This is simplifying polynomials and the distributive property. So we talked in the first part about multiplying monomials, which are single terms, by other monomials, binomials, trinomials, sort of a strategy for making sure that you don't have any terms left behind. And then we moved on to learn how to multiply a binomial by a binomial, which we did in part B. Part 1, A, B, and C. And now we're going to move on to just same idea, just maybe a slightly more complicated application. So let's jump right in at D. We have 2x plus 4 times 3x minus 8. Both of those are binomials. How do we deal with that? We are going to distribute. So recall that we multiply our first term by our first term. So we have 2x times 3x. That's going to give us 2 times 3 is 6, and x times x gives us x squared. Moving on to the next one, we have 2x times minus 8, so that's going to be minus 16x, plus 4 times 3x, 4 times 3 is 12 x's, and lastly, plus 4 times minus 8, minus 32. So a binomial times a binomial should give us 2 terms times 2 terms should equal 4 terms, and we have 1, 2, 3, 4, which is awesome. And now we simplify. Which terms in here are alike? Well, hopefully you're starting to see now that this pattern includes 2 terms in the middle, typically, that are going to be similar. Not always, obviously, but in this case, it's something you're going to see a lot of in your grade 10 year. So we are going to simplify that. There's our 6x squared. We have minus 16 plus 12 is going to give us minus 4x's minus 32. And what you'll notice is that there is a common factor in 6x squared minus 4x and minus 32 of 2. We're not going to do anything with that at this point. We're going to be looking at how we can utilize that information in unit number 6. So we still got some time in front of us. Or I guess not. Yeah, it is. No, sorry, unit number 3, I should say. Okay, let's have a look at this one. This one's got some extra stuff. It's 2 times x minus 4x minus 3 times 4x plus 5. So we have a monomial times a binomial times a binomial. Now, there's no wrong way to do this, but there is a wrong answer. So what I'm going to recommend, let me erase some of these things here. So what I'd like to propose that you do when given a monomial times 2 binomials is that you do the binomial expansion first. Now again, this isn't a rule, this isn't something you have to do, but it prevents mistakes, and I'll show you why shortly. So if we are going to expand out this binomial by a binomial, we would do our 4x times 4x. So there's our 2, haven't dealt with that yet, but now we have 4x times 4x, that's going to give us 4 times 4 is 16, x times x is x squared. Then we have 4x times 5, so 4 times 5 is 20 x's. And minus 3 times 4x, that's minus 12 x's, followed by minus 3 times plus 5, which is minus 15. Now, I would always recommend that we simplify as much as we can before we start the next step. So let's simplify this a little bit. We have 16x squared, we have plus 20 minus 12, that's going to be plus 8x minus 15. Okie doke. So now we have expanded out and simplified the binomials. We now have a monomial times a trinomial. So this is going to be 2 times the first thing. So that's going to give us 32x squared. And 2 times the second term, which is plus 16x. And 2 times the last term, which gives us minus 30. So this is the strategy that I recommend. I'm going to say it again. The reason that expanding it out the other way is sometimes problematic, and you don't need to write this part down, but if you could imagine that you started by multiplying 2 by 4x, so that would be 8x, and started multiplying 2 by minus 3, that would be minus 6, and then you have your 4x plus 5. What you'll notice is the way that you've written it, it implies that minus 6 should be multiplied by these two, but it omits that 8x also needs to be multiplied by these two terms. So it's not that multiplying by 2 first is incorrect, it's just that when you do it, remember that both terms need to be multiplied by the remaining binomial, 4x plus 5. I find by multiplying out the binomials first, you circumvent a possibility for errors there, in my experience. Okay, so here we have minus 3 times 4x plus 3 all squared. So, as before, your temptation is going to be to say, oh, this is going to be 16x squared. Oops, that's an eraser. This is going to be 16x squared. This is going to be plus 9. Remember that when you expand it out, there will be a middle term, so don't fall into that trap. Do not be tempted. Insist to yourself that you do the rewrite step, which is minus 3 times 4x plus 3 times 4x plus 3. And again, I've already written this step in. I would recommend doing multiplying out the binomials first. So let's do that. Here's our minus 3. There's our bracket. So we have 4x times 4x. That's going to give us that 16x squared. We have 4x times 3. That's plus 12x. We have 3 times 4x, which is plus 12x. And we have 3 times 3, which is 9. Again, let's simplify here a little bit before we move along. You'll notice again that those two middle terms, they're the ones that are common, so we actually have plus 24x's, and there's our plus 9. So remember, we have a negative leading term here, so we have to make sure we keep that in our mind as we're moving through here. So we are going to have negative 3 times 16 is negative 48x squared. Sorry, that's this one right here. Then we do negative 3 times 24. That's going to give us negative 72 x's. And lastly, minus 3 times plus 9 is minus 27. So, saying it one more time, when you're given two binomials to multiply by a monomial, do the binomial expansion first. You're going to save yourself headaches and errors. Please, please, please. Okay. Let's look at an application style question to finish up here. We are being asked to write an expression for the perimeter and an expression for the area. So here we have ourselves a little rectangle, and we have one side being measured as 3m minus 2. I've chosen to call that the width, and another side measuring 5m plus 1. I've chosen to call that the length. Doesn't really matter. That's just what I've done, so we're all on the same page. An expression of perimeter, so the perimeter of a rectangle is to take 2 of the lengths and add them to 2 of the width. That's width. That gives us this whole distance around the outside. That's what perimeter is. So let's work through this. Our perimeter then is equal to 2 times the length, and the length, as I designated over here, is 5m plus 1 and plus 2 widths. And the width, as you remember, I designated 3m minus 2. So there we have it. What you'll notice, hopefully right away, is that we have an opportunity for expansion here. So let's do this monomial times this binomial. That's going to give us 10m. And monomial times the second part of the binomial, that's going to be plus 2. And then same thing, let's do the second half. So plus 2 times 6m will be 2 times 3m gives us plus 6m. And plus 2 times minus 2 is minus 4. So let's gather together the terms that are alike. There's actually a couple sets this time. 10m is like 6m. So when we combine those, we end up getting 16m. And we also have alike a plus 2 and a minus 4. And when we combine those, plus 2 minus 4, we get a minus 2. And that is a suitable expression for our perimeter, expanded out and simplified. And that's important to remember as well. Now when we're talking about area of a rectangle, as we know, is length times width. So our length, which I designated over there, was 5m plus 1. And our width was 3m minus 2. Again, this is looking very much like what we just did above, so let's expand out these binomials. We have 5m times 3m, that's going to give us 15m squared. We have 5m times minus 2, that's minus 10m. We have plus 1 times 3m, that's plus 3m. And we have plus 1 times minus 2, which is minus 2. Let's gather together the terms that are alike. There's a couple m's hiding there, so we've got 15m squared. So minus 10m's plus 3m's is minus 7m's, and there's our minus 2. And this is an expression of the area of that rectangle. So there's our lesson. Hopefully this multiplying binomials by binomials, or monomials by binomials, or a binomial, hopefully that's making sense. Again, and I say this often, please write out a good copy of what we've done here in our examples and for your notes, either on the blank notes that have been provided in the lessons, or just even in a notebook. It doesn't really matter. The reason you rewrite these in such detail is so that you can reference them while working through the homework. The homework typically closely matches, at least the bulk of it, closely matches what we've done in the lesson. So if you're stuck, refer back to similar looking questions in the lesson. You can only do that if you have a good copy of them that you've made. So please do that. Good luck with the homework, and we'll see you in lesson number 6.